Good morning, students. Maximum current from the cell, battery cell is smaller is enter resistance, EMF is E, capital E we can take. I can write this color is style T actually. It is not epsilon, bigger size. Looks like similar as epsilon. This resistance, external resistance is R. Current is passing I through external resistance also, internal resistance of the cell also. I is same through R and R, that means what R and R coming in the series. Smaller is internal resistance of the cell, capital is external resistance. Okay. If external resistance is there, it limits the current. The function of this resistance is what? More resistance means less current. As the resistance increases, current decreases. But if you take a battery cell and if you connect the two wires of the battery cell, short circuit like this. Cell is there, you take wires, you take the battery cell, and from this wire you take. And if you connect it to a battery, some bulb or any electrical devices, what happens is that this device resistance is capital, limits the current. Internal cell is R. But in case by any reason, if these wires touch here, they touch like this, then what happens is, directly touching means if you imagine these are the thick wires, their resistance is less. Current always prefers the low resistance path. If chance is there for the current, high resistance, low resistance, it prefers low resistance path. Means more current will pass through low resistance, negligible current. If low resistance is zero current pass through the resistance. That means if this resistance is zero, current won't pass through the resistance only. Now this resistance will not have any function in controlling the current. So what happens here is, you are connecting now the wire, loose connection of the wire is connected directly. This is called the short circuit. Short circuit means current has a short path. Means low resistance path is called the short circuit. So instead of current passing through this resistance devices, any devices you take, directly current passing through the wires only. Now what resistance is present is only smaller. Smaller we cannot make it zero practically. Theoretically ideal cell will say internal resistance zero, but actually it will be there. Now what happens is current will be maximum. Current is called the maximum current. Short circuit of the cell, if you have taken two wires connected shortly like this, no resistance is present. There is no external resistance, and two cells wires are two electrodes of the wire cell are connected with a low resistance wire. This is called the short circuit of a cell, and current will be maximum. That expression I will discuss. If any external resistance is there, current is not maximum, it is limited by the external resistance. So this is called the short circuit of a cell. And problems also they will ask related to this maximum current. The problem with this maximum current short circuit is the cell will damage. Also maximum current increases means that it heats. The small R may be there. Internal resistance of that will, because the internal resistance metal will be heated up. The chemicals inside the cell will be heated up and the cell may damage. Another big problem is this short circuit. If the large current is there, like in the houses etc., the current has to pass through the devices and come. And refrigerator, whatever you take. But instead, directly connect two wires touch it. Neutral phase they touch it means we call it short circuit. In the short circuit, what happens is the current will be maximum, very high. There is no zero resistance. Zero resistance is possible only for the superconductors. So this is there is small resistance previously, but now it is considered into consideration. Even the wires also gets heated up. This cell is getting heated up, and wires also gets heated up. But wires is having what on the surface? So PVC coating will be there, plastic coating will be there. That catches fire. So short circuit fire catching they will say that is because the current increases by large amount when the two wires are touched and the insulation catches the fire, and any surrounding materials like wood, other materials or plastic materials are there, cloths are there, they also catch the fire. So that will be the problem with the short circuit of the cells. So you never try to short circuit the cells, any cells. And specifically the dry cells not a big problem. Dry cells means the cells we are using in the houses have the dry cells. They are called, they are naturally not dry, but they are called dry cells. Dry cells have high resistance, internal resistance compared to that of the rechargeable cells. Dry cells are not rechargeable, they are primary type cells. They cannot be recharged. But rechargeables like nickel metallic hydrides used in the mobile phones, batteries, they must not be heated. If they are heated, then they catch the fire also. Whenever the temperature passes beyond particular limit, that catches fire. So that nickel metallic hydride and even lithium polymer cells. Lithium polymer cells, LiPo cells are used for the hobby purposes, remote control aeroplanes, remote control cars. In that rechargeable cells are used. They are called the LiPos. The advantage of the lithium polymer, their form is lithium. Lithium is it can catch the fire easily. So if that cell is heated by charging the current exceeds the limit, if this charge that heated, or due to short circuit when it is heated, it catches a fire inside the cable. That metal will be catching fire and it explodes. It's not a dangerous explosion like bomb, cell phone explosion also not really dangerous, but it can catch the fire, surroundings can catch the fire, but not really big harm. Like in the social media they say that cell phone explode, person explode, pieces that will never happen. Person won't become pieces, nothing happens. It's not much dangerous, but it should not be heated. These materials, chemicals are present means that battery must not be heated. To take the calculation, this E is EMF of cell. R is internal resistance of the cell. EMF of a cell, internal resistance of a cell. Capital R is external resistance. I is current, not maximum current. R and R are in the series only. R comma R are in series. Therefore, EMF E equal to I into R plus R into. Or current is nothing but equal to E by R plus R. Condition is now we are going for the maximum condition. If external resistance is not zero, not there is different. If external resistance not there means what is going to be open circuit. Open circuit resistance is infinity. So you should not say external resistance is not there. We should not say external resistance is short circuit. Means external resistance is zero. If external resistance R equal to capital equal to 0, capital equal to 0, then I becomes now resistance decrease. Resistance is coming in the denominator. Whenever the resistance decreases, now current becomes a maximum. Then current is maximum. I becomes I maximum, and I maximum formula now becomes equal to E by smaller one. This maximum current is limited or controlled only by the internal resistance. Maximum, it is a short circuit current of cell depends only on internal resistance of a cell. Please remember, whatever I am putting in the box, you must also keep the box because they are the formulas used for the numericals. Okay, maximum current problem also they may ask you, and they will ask the ratio. They will give external resistance also and then short circuit current also. And what is the ratio of the maximum current and current they may ask. So ratio here. Yes, please. This maximum current depends only on the internal resistance of a cell. Okay, and for ideal cell, internal resistance is 0, but practically there is no ideal cell. We have discussed already. And usually the dry cells usually in house, usually in the houses, they are not rechargeable cells, or not rechargeable. And have high internal resistance compared to rechargeable electrolyte cells. but that is in the form of a paste. But here it is not in the form of a paste, it is like a liquid type thing. Lead acid is complete acid only will be there, sulfuric acid and lead electrodes will be there. Okay, in that water, distilled water is added to make it a dilute. After prolonged use of water applied to the cell. After prolonged use of a cell, the internal resistance changes, increases, becomes dry, more dry. When electrolyte becomes dry, concentration increases, internal resistance increases, current decreases. These are the extra points. These are related to extra points. After prolonged use of a cell, its internal resistance, I am not telling you the mechanism involved in this, it is not required for users. Its internal resistance increase, hence the current decrease. Hence the current is decreasing. Next, differences between the electromotive force and the terminal field. This is prolonged. After prolonged means of long days of usage. After prolonged use of a cell, its internal resistance increase, hence the current decrease. Dry cells used in the houses are not rechargeable and have high internal resistance compared to rechargeable electrolytic cells or electrolyte cells. The difference between electromotive force and terminal potential difference of a cell. This will be asked for 2 marks question. Difference between electromotive force and terminal PD means terminal PD I am using for potential difference. We can take in the form of a table also, which is left to your choice. EMF. Here, terminal potential difference. Symbol is V. EMF is. What is EMF is? It is the potential difference of the cell when current is not passing through it. You can say it in the open circuit also. EMF is the potential difference across of the cell, we can say, across the cell when current is not passing through it. EMF is the potential difference across the cell or across the terminals of the cell when current is not passing through. You can simply say EMF is the voltage of the cell or the potential difference of the cell. Across cell also not opposite use, that is the left choice. When current is not passing is important point. What about the terminal PD? Terminal PD is the potential difference across the cell when current is passing through it. Potential difference is the voltage across the cell when current is passing through it. When current is passing through it. What about this EMF doing? EMF is the actual voltage. It can move the current through external resistance also through the internal resistance. Whereas the potential difference is only the work done to move the charge only through the external resistance. EMF is the work done. Is the work done to move unit charge, or to move the current also, to move unit charge through external resistance and internal resistance. External resistance R and internal resistance R of cell. What are the terminal components? This is first point. This is also second difference. Terminal P is the work done. Terminal P symbol is G, we take is the work done to move unit charge. That will be defined as current we are talking about the unit positive charge. So we take it as a positive charge. To move unit positive charge only through external resistance. So this electromotive force is equal to work done to move the charge, but work done to move the charge through internal resistance also, external resistance also. Here also same thing will be formula V equal to W by Q only, or Q naught will be. But here this work is W by naught. Work done is to move the charge only through external resistance. So if you take this diagram and use separately. W is work done to move charge Q through R W prime through R W prime is work done to move the charge through external resistance. That is the internal resistance and external resistance. And the units if you take both are scalars, this is also potential, that is also potential for actually. Units are volt, it is also volt. In dimension formula also same for electromotive force and this one. That is not coming as a difference. They don't come as a difference. I just give the relations of extra force. EMF terminal P. Terminal P means now same SI volt, same SI volt and same dimensional formula. This dimensional previous class I have already discussed. That is EMF dimension formula, volt dimension formula, same. What is the dynamic formula is work by charge. What dynamic formula is whatever you take as this is also work, this is also work only. Work or energy is mx square t minus 2 by this charge means current into time means at we can take or it we can take. So dynamic formula if you check up this becomes equal to mx square t minus 2 by I into t. I equal to q by t equal to I into t. T equal to no minus 3 minus 3. So I minus 1 mx square t minus 3 I minus 1 power by current relationship. And if you don't remember the dynamic formula of this, we remember the dynamic formula of the power already in it. In the previous class we discussed the power power formula of electricity. What is the formula for the power is? Power equal to electric power is equals to voltage into current we have taken. I want the dynamic formula of the volt V. Then what is V equal to P by I? Power is work power is usually known as dynamic formulas. So power by current dynamic formula directly can remember easily. So different formulas are there. Dynamic formula remember we go for the easiest methods. V is equals to dynamic formula is nothing but equal to power by current means power is ml square t minus 3 into a minus 2 or ml square t minus 3 I minus 1 is the dimension formula of the power. One more thing they will ask is when does electromotive and thermal potential are equal? When do they become equal? That is from the equation also you can check out when do they become equal. Condition or conditions when EMF and thermal heating of cell become equal. This is required for the numericals also. One more question. When do they become equal? We have the external resistance connected across the cell. External resistance is also sometimes called the load resistance. That is the one which is absorbing the electrical energy and converting it into other forms. It is also called the load. Load resistance is the one which absorbs the electrical energy. Current is I. A is EMF, R is external resistance. Sorry, I should take the resistance first. EMF of cell is internal resistance of cell. Kappa is external resistance. I is current. The formula relation and V equal to IR is thermal heat. Of cell it is nothing but voltage across the external resistance. I into R is also voltage across the external resistance. So voltage is P across external resistance. Okay, that relation we have is E equal to I into R plus R. If we expand it further, we have the relation already previous class. IR plus I into R. This IR is V. E equal to V plus IR. E equal to V plus IR is a relation to E and V. We are making it. When this E becomes V, is whether I should be 0 or R should be 0. Small r should be 0. So this part if it becomes 0, then E becomes equal to V. When it becomes the open circuit, if you are taking cell is the open circuit, there is no current. There is no current. And one more thing, the material wire is you are taken and connected to the battery cell. Resistance is counted only when current passes through it, because resistance is something opposing the motion. If the current is not passing, you should not consider the resistance only. I have taken the resistance value will be knowing only if the current goes through. If current is not passing, means that resistance should not be counted. Okay, it should not taken into consideration. When current is not passing, open circuit line. Okay, and in this case, this I is limited by the external resistance. But if the external resistance is there, but internal resistance is 0. Internal resistance 0 means ideal cell. For ideal cell, smaller is 0, E becomes equal to V. This part is 0. Open circuit, if you have taken current I equal to 0, then in that case also again E becomes equal to V. Two conditions will take. One is either internal resistance of the cell is 0, another thing is cell is the open circuit, current I equal to 0. These conditions will be true. This point is important. EMF and terminal current are equal. That means E equal to V if I equal to 0 or smaller. That is, if the circuit cell is the open circuit or ideal cell with internal resistance 0, in both the cases E and V are equal. That means, if current through cell is 0, comma, cell is in open circuit or cell is ideal with the 0 internal resistance, with internal resistance 0, then E equal to V. Both will become equal. Electromotive force and magnetic potential difference are equal only if conditions is remove the points. Next we have is charging and discharging. Which is more? EMF is more or terminal PD is more? Okay, that points we will discuss next. Discharging of a cell. Discharging of a cell. In the discharging of a cell, current is coming. Generally, we talk about the current coming out of the plus terminal means discharging. So, very rare cases we use the charging of a cell problems. Discharging of the cell means current is coming out of the plus of the battery, coming out of the cell from the battery plus and goes like this and enters from minus. Okay, so you take a cell like this. Current comes out of the cell from positive terminal. Then EMF is greater than V. Electromotive force is greater than terminal current difference. Internal resistance is smaller. This important difference across this is V. This is EMF. EMF direction is from minus to plus. In that case, E is equals to V plus IR. E is greater than V. If the current is taken out of the cell, the potential difference between this A and V terminals is E equal to V plus IR. If current is going into the cell, means when charging of the cell, reverse case we have to discuss, that we will discuss in the next class. I will repeat this point again in the next class.